Welcome. The webinar will start in 30 seconds. Welcome. Are you looking for a unit testing tool for C and C++? Cantata is a cost-effective, automated unit integration testing tool for embedded code. Developers can build, run, and analyze unit integration tests over multiple targets. It is highly configurable, fully extensible, and provides a write-once deploy anywhere framework with the same tests executed across multiple platforms with a simple switch. Cantata Autotest can generate and run tests in a single click with optimized test vectors to drive the code through all required code paths. Coverage analysis is provided for all metrics, including statement, decision, and MCDC. Detailed reports allow developers to pinpoint untested code. Requirements in industry standard formats can be imported from management tools. Versions and variants of requirements are filtered and linked with an intuitive drag-and-drop interface, alongside Cantata tests. Links and test results are automatically exported along with the code coverage obtained back to the management tool for full bidirectional traceability of test to requirements. Cantata is certified for use across all safety-critical industries. Reduce time and effort. Accelerate your testing with Cantata.
Hello, everyone. Thanks for joining us today for this webinar, Accelerate Unit Testing Safety Critical Software with Cantata. I'm your host, Georgette Callas, Channel Sales Manager here at QA Systems. Joining me are speakers, Adam Mackay, Integrations Manager at QA Systems.
Hi, everyone.
And Matt Davis, Managing Director at QA Systems.
Hi, everyone.
Today, we're going to discuss unit testing safety critical software and how using Cantata accelerates that. Please note that you'll be muted throughout the webinar. If you have any questions, do feel free to type them into the question window at any time. To open this, use the orange arrow in the top right of your screen. We will answer them during the Q&A portion right after the discussion. The webinar is being recorded, and we will send you a link to that afterwards. Before we go any further, so that we can best understand our audience today, please answer the 3 questions in the pop-up on your screen. Click Submit when you are done, and we will show the results in the Q&A session at the end of the webinar.
So to give participants an idea of what Matt and Adam will cover in this discussion, let's have a look at the topics we're going to talk about over the next hour. We will start with a brief look at what's required by international safety critical software standards. Then discuss how Cantata fits into this landscape at a high level. A closer look at requirements-based testing, before moving on to code coverage. An interesting look at how Autotest, automatic test generation, can be used, what reporting is available, and how Cantata can fit into your existing project development environment. We will wrap up by putting your questions asked in the chat to our speakers. That's a lot to fit in, so over to you guys.
Thanks, Georgette. Whichever safety critical industry you're working in, there are international organisations which set standards for the development and testing of the software. The main standards are these on screen. All have the concept of safety integrity levels, which correspond to the harm which could be happening if things go wrong with the application. However, while the level of prescriptiveness defined does vary between the standards and by safety integrity levels within them, they actually have a lot in common. So as an overview, let's look at a traditional V model and the order of main verification activities which all the standards require. The requirements and design are decomposed into various levels and implemented in source code. This provides the basis for 3 types of testing activities at all levels, from unit tests up to whole system tests. Firstly, tests need to verify that the code does what it should do. So these are functional and non-functional requirements, such as safety or performance. Next, that the code should not do what it should not do, with what you could call robustness testing. And finally, as a backstop, all the standards require some form of check that the code is tested enough, so require sufficient code coverage. For unit testing, the main safety critical standards recommend the following test methods: verifying functional requirements, non-functional requirements, various techniques for robustness testing, and finally structural coverage testing.
And Matt, am I right in saying that Cantata supports all of these methods for unit testing?
Absolutely, Adam. At QA Systems, for the last 25 years, we've been helping our customers with automated tools to optimize safety-critical embedded software and accelerate their standards compliance. But beyond the Cantata tool itself, which enables our customers to efficiently use all these testing methods at both unit and integration testing, the company are committed to easing the path to certification for our customers for their safety-critical applications and devices. So no matter what the standard, we provide comprehensive guidance, technical advice, and training, and of course tool certification or qual kits up to the highest safety integrity levels for each of the standards. These kits include a comprehensive safety manual for safety-related testing and a very detailed standard briefing, setting out exactly line by line and table by table how Cantata can be used to meet the objectives or requirements of that standard. So, before we take a deeper look at the challenges of requirements-based testing, Adam, can you explain how Cantata fits in to what standards require, with a quick overview of what's in the tool?
Let's have a quick look around the Cantata interface. So, Cantata is built on Eclipse and is able to run on Windows and Linux systems. It's got a very appealing UI that's easy to use and configure, and in addition, the test build environment can be abstracted away from the desktop IDE to easily enable tests to be executed in regression testing, CI, and target environments. Eclipse in itself is a full-featured IDE, allowing you to edit and build your code in situ. Cantata adds its own menu system and sophisticated plugins to the Eclipse platform to enable you to construct, maintain, and run your tests. The Eclipse plugins have deep integration with the IDE and enable a number of testing views on top of the standard Eclipse platform. Let's switch to the Cantata perspective. This gives you a Test Explorer view in addition to the traditional Project Explorer view. I can switch between this and the Project Explorer to see things at the file level. I can see the components of my project, the software under test. I can open up header files and source files for maintenance on the fly. Full IDE features are available. Let's go back to the Test Explorer view and see all the test cases that I've created in this sample project. Switching into the test case editor, I've got a full graphical UI where tests can be created and edited, the test scripts and test cases that I've constructed to run against the software under test. With Cantata, you maintain your test scripts either as C or C++ code, so they're readily readable and transparent. It's very easy for developers to understand what's going on under the hood of your testing project. Let's have a closer look here at one of the test scripts. They're nicely commented and well structured, and the content of them can be edited directly as code, or I can switch back to the UI, which enables you to set and maintain the same test data in a user-friendly way. Cantata takes care of generating the build framework for your tests and helps automate many of the steps involved in constructing a unit or integration test. It's a completely integrated platform. So I've got a suite of tests here which I can run directly just by hitting this run icon. In the console output, you can immediately get some quick feedback as to the status of your tests. You can see any compilation issues, and after the test is built, we can see the number of passes and failures. On this sample project, I do have some failures. The results are represented in the icons next to the individual test cases, and I can drill down and see exactly what the failures may be in my test suite. Here we've got a quick overview of the code level coverage, so how much of the software under test we've hit with the test suite that we've built up so far. I can either view this at a high level, or I can get a color-coded source view to show exactly what's going on right down to the code level. We'll come back to coverage later. Something that's critical when you're dealing with safety code is the results log that you submit to the certification bodies to prove your code has been tested to the required standards. And on top of that, you need to be able to generate a detailed report so that you can be assured the tests have been run. The Cantata ASCII results file is definitive and accepted as certification evidence, as is this HTML view of the same report. The HTML view is a user-friendly way to view the status of your tests and useful to store as a log of your testing effort to date. In addition to these reports, you can store the complete test results on a Cantata server component for consolidating your testing effort across your project or projects. I'll show you what this looks like in a bit more detail later. So let's leave these two files on the screen for the moment and talk a little bit more about the importance of driving your testing from requirements.
Thanks for that, Adam. We all know that safety critical standards state we should do requirements-based testing and bidirectional traceability of requirements with tests. So let's discuss what is needed for effective requirements-based unit testing. Of course, in any complex system, there's going to be a level of decomposition from high-level requirements to low-level requirements or even designs. Most of our customers define what each unit should do in these lower-level requirements. As our integration manager, you're responsible for integrating Cantata with the requirements management and ALM tools, which our safety-critical customers use, Adam. So, can you explain what formats unit-level requirements you see being used?
Okay, well, the formats we see our customers use as unit-level requirements often depends on the tools they define the requirements in. So, for example, many just use native language descriptions of the intended behavior of the class or functions under test, and that can be simple in almost any tool, which is why lots of people use text documents or Excel. But more powerful tools provide many requirements management activities such as version and variant branching, reviews and status, and of course traceability. They also support more flexible formats for defining the requirements, everything from tables, numbers, pictures, diagrams, models, and even videos. More and more of our customers are using all of these.
And for these low-level requirements to be useful for both implementation of code and unit testing, they'll need to be validated against several criteria. That means being decomposed from high-level requirements, being correct, complete, unambiguous, and of course, logically consistent. When it comes to creating the unit tests, those requirements will need to be of sufficient detail to define for each test case vector the preconditions, the inputs, parameters and variables, for example, the expected behavior, including function calls within or to outside the unit, and of course in the right order, expected outputs, and any postconditions. It's not uncommon for the process of creating the tests to identify gaps in the requirements, and the bidirectional requirements traceability with those tests ends up improving the quality of both.
The same, of course, is true for higher level, more integration-style tests, where the focus is more on the interactions and interfaces between the units.
Certainly. What we see is that for requirements-based unit or integration tests, the most effective strategy is aligning a level of detail in the requirements with the degree of code coverage required by the safety integrity level. That's because the structural coverage testing is supposed to plug the gaps left after requirements-based and robustness tests. So more detail, less gaps to plug. Adam, I think in our experience, we would say that there's often some degree of confusion around the term coverage, particularly when it comes to requirements-based testing. So this is how we at QA Systems understand and define the terms. Requirements coverage is the percentage of requirements which are verified by tests. Code coverage is the percentage of the code executed by tests. And test coverage is the percentage of tests that have been executed and pass. We have a whole white paper on this subject called C and C++ Software Testing, Am I Covered? Might be worth a read. Adam, can you explain why measuring these three types of coverage matters?
Well, if you want to prove that all of your requirements have been verified by tests, you need to show which tests are verifying which requirements and measure the total. Requirements coverage shows how many and which of the requirements have been verified. That's where the bidirectional requirements traceability comes in. The ability to identify which requirement is verified by which test quite often means that it's helpful to have both accessible in the same tool. But that's only one of the things that you might want to store in your requirements management tool. As requirements get traced to all sorts of things, code items, review records, contracts, etc., all of the software safety standards also require full bidirectional requirements traceability. In other words, the ability to link a requirement to a test and a test back to a requirement. So this matters for compliance certification data. Code coverage measures what code has been exercised by the tests. The safety integrity level will define which particular metrics are used for that measurement and need to be supplied as test evidence. What code is exercised by the requirements-based tests to verify it does what it should do is not, however, usually all the code. That's because programmers will add things like defensive programming guards, so the software does not do what it should not do, and also initialization code. Test coverage is simply a measurement of tests that have actually been run and pass. That matters so you can demonstrate the completeness of test execution on the correct versions of the code.
We have our requirements defined in our requirements management tool in whatever formats. We want to see all the requirements or design details inside Cantata, of course, so that we can create and check that the test cases do in fact verify the code implementation does what it should do. But also trace, i.e. link the requirements with the appropriate test cases and record that along with the test execution status back in our requirements management tool. Firstly, all of these tools can export their data via CSV, Excel, or, the most full-featured of all, in the RecIF requirements interchange format. That requirements data can be directly imported into Cantata. In the Cantata trace view, a drag and drop tracing of requirements can be made linking them with the appropriate test cases. And then when the tests are run, for example as part of a batch regression test or continuous integration pipeline, the test information with the links, results of that test run, and the code coverage obtained can be exported straight back to the requirements management tool for full bidirectional traceability, along with all the other traceability in a requirements management repository.
So let's take a quick look at how all that works in practice inside Cantata. I'm starting here with a simple function, my software under test, which is a monitor temperature function with 3 branches. We're reading an input from a temperature sensor, and this is the logic to determine how to handle that input. I've got some requirements for those defined, and we're going to look at those requirements using the Cantata trace functionality. The first thing that I want to do is import my requirements set. Now, Cantata supports standard RecIF documents and also CSV files. It's very easy to get the requirements, including the textual details and diagrams and tables, into Cantata. I'm going to bring in some existing requirements here and load them into the selection window. So we can see that we've got a number of defined behaviors that we want our software under test to exhibit under different conditions. These need mapping directly to the behavior of our tests. I can open up those requirements, and here we've got the current specs from our requirements management tool, That could be Doors, Polarion, Codebeamer, whatever you might be using. And I can review those in situ inside the same interface that I'm using for my testing. There's no need to switch between tools, so it doesn't interrupt my workflow at all. It allows me to view everything in one place. This also means that I can incrementally review requirements at the same time as I'm going through the development of the code and the tests, and we can see how we're living up to those requirements. Having my requirements in place, I'm going to select the ones that match up with our temperature control unit here and bring them through to the next tab, which will enable me to link those requirements to tests as I build them up. Now, I don't have any tests at the moment, so let's use the power of Cantata to give me a quick testing framework. I'm going to use automation to analyze the software under test and determine the various paths through this piece of code. And very quickly, we've identified 4 unique paths, and Cantata has given me a description as to the conditions required to go down each code path. It's also pre-populated the test case with those conditions, so everything is immediately runnable. Now, using this description information, I can see that the software we've got here has been quite well written to match up with the requirements. The automatically generated test cases align very well to what we've imported from our requirements tool. So I've got things like what happens when the temperature of a sensor is above a maximum threshold, what happens when it's within acceptable bounds, etc. To save time in this demo, all these test cases have been automatically generated, but I could have generated these test cases manually or used a combination of automated and manual test case generation to achieve this point. So everything's all linked through now. I've got my 4 test cases in the Cantata trace window. I can click through those and you can see the test case editor updating dynamically to match. I can drag and drop my test cases that match the imported requirements and link the two together. I just pick up a test case and bring it over and drop it on a requirement. And this sets up our bidirectional linking between the requirement set and the test case. And the drag and drop works both ways. So I've switched things around here now, and instead of picking up a test case and dropping it onto the requirement, I can pick up a requirement and drop it onto a particular test case. This helps me identify any missing requirements or any test cases that I may need to add into my test suite in order to exercise the various conditions that are defined. I don't need to stick to a one-to-one mapping. We could have a one-to-many mapping, so we can have several test cases linking to a single requirement if required, or indeed I can have a single test case that satisfies multiple requirements. And that's how easy it is to link our requirements to a suite of tests. It's nice and intuitive, it's drag and drop, and now I can execute my suite of tests and get those pass-fail results and also the code coverage information that those tests are achieving linked straight through to individual requirements. Cantata maintains the linkage between those test results and the requirements.
Adam, requirements are never fixed forever, so can you please show what Cantata Trace does to help manage traceability when there's a new version or variant of the requirements?
So if there's a change or an additional requirement, I can add a new set of requirements into Cantata. So I go back to import, choose the updated set of requirements. I can reuse the stored assignments from my previous import. I can do a comparison between the previous set of requirements that I brought in and any updated requirements. So I select the 2 sets to compare against, and Cantata will analyze those 2 requirement sets and highlight either changed, new or deleted requirements, allowing me to pick them up and link them into my testing suite, or indeed develop new tests to hit those changed or new requirements. So I'm going to click changed here, and you can see we've got a few extra requirements that we need to satisfy. Again, using the drag and drop, I can associate any tests with those new requirements. Once I'm happy the linkages are complete, I can then export my requirements data using the RECIF format here, and this will export all of the test results linked to the requirements and enable me to import that as an artifact into my requirements management tool. Using this workflow, it keeps the test results in a central location, enabling your entire team and project management to monitor the progress of your testing effort against the defined requirements.
Thanks, Adam. So we've seen how requirements traceability enables demonstration of requirements coverage. In this table, you can see for each of the main standards the lowest safety integrity level, which recommends 100% requirements coverage for high-level and low-level requirements. For all the standards, at the very lowest SIL, all the tests need to have been executed and pass, demonstrating 100% test coverage. The third coverage measure is code coverage, but it's not a single measure, rather a set of metrics, which each measure the code constructs in various levels of detail. The standards are not all the same. This applies not just to the code coverage, but generally to the whole verification requirements. The simple rule of thumb here is the more people die in one go when the software fails, the more thorough the testing needs to be. So the higher the code coverage requirements. You'll note that all the minimum SIL requirements are for 100% coverage of a certain metric. The lowest, easiest to achieve metrics are function entry point and function call rule coverage, where just invoking or calling the function is sufficient. The highest, and certainly the hardest to achieve, is MCDC, Modified Condition Decision Coverage, where each condition within a decision is shown to independently affect the outcome of that decision. A couple of standards also require coverage of control flow and data flow couplings. For each standard SIL, it's important to note that not all code coverage needs to be obtained during unit testing. Indeed, some metrics are more designed for integration testing, and certification bodies, such as for DO178C, also give more credit for achieving code coverage at these higher levels of testing than at lower ones. The next consideration is on what platform the tests are executed. In general, the rule is that the higher the SIL, the closer to the actual target operating environment should be where the tests are run and the code coverage obtained. One thing is certain. It is impossible to achieve 100% code coverage in any complex system for any of the more rigorous metrics without white box unit testing. So, the role of code coverage is to act as this backstop check that we've done enough testing, whether it's requirements-based or various robustness tests, and that there is no executable code left untested. Having the ability to integrate code coverage into the unit tests, then, makes these more effective as it can pinpoint these gaps. Cantata code coverage can be used standalone with whatever drives the code, or is integrated with the unit tests, and both these styles can combine to obtain a complete code coverage evidence for compliance to any SILs for these standards. Okay, back to you, Adam. Please can you briefly show us code coverage integrated with Cantata unit tests?
Monitoring code coverage is a great way of directing your testing effort and also verifying how thoroughly executed your software under test is. Let's switch to a different version of the same project now. Here, again, I've got the same temperature monitor function, but you can see I've started to flesh it out a little. We've got functions in 2 files, and I've built up a number of tests against that code that I can see in my Test Explorer. At the moment, we've got 9 tests. Some of them are passing and some are failing.
How do I know which set of coverage metrics I need to use for my particular standard and SIL?
For code coverage, Cantata supports all the main safety-critical software standards and has built-in rule sets for the coverage demands of the various standards. You can see here ones for ISO 26262, DO178 and so on. And towards the bottom we've got some more generic coverage rule sets that we can apply. And we're not limited by this set. If you've got your own in-house rules, maybe you're interested in some particular combination of code coverage metrics, you can define your own rules and add them to the set here to apply to all of your tests. For this particular set of tests, I've chosen statement, call return and decision coverage. For some quick progress feedback, I can hover over the software under test to see where we're at with our testing efforts so far.
That's not too bad, getting 95% statement coverage and 90% decision coverage. Can we explore this in a bit more detail, please?
If I expand this out, I can see I've fully exercised my temperature conversions.c. I've got 100% coverage for all metrics across that file. For temperature monitor.c, however, there are some coverage gaps. I can delve in further here, and I can see that for this one particular function, we're failing to meet our coverage goal. On the coverage viewer pane, we can see source code coloured according to coverage, so the actual source code that we're building our test against, and you can see a lot of it is green. But indeed we've got some red, which means we've not developed a test to hit that part. There's also some in yellow, which means partially covered. So you can see this if statement here, it's only been partially covered. I expand that out and we can see that we've hit it twice in the false state, but not at all in the true state yet. So we know now, with this particular rule set, we need to develop a test that hits this differently in order to satisfy our coverage requirements.
It's worth mentioning that you can gather code coverage both in a host native environment, as we're running here, or indeed you can build the same tests using a cross-compiler and execute them gathering the coverage data from your embedded target.
So let's filter down and explore this coverage data in a little more detail by opening up our Coverage Results Explorer. We've got a very detailed view showing us the items we haven't covered with our testing. We've got our color-coded highlighting that we can explore across our entire project codebase. With the flexible Cantata instrumentation, I can gather coverage data as driven by the testing environment, and I can also build an instrumented version of my software to be exercised in standalone mode if required. And this means I can drive my software using system or user tests and combine that coverage into the overall coverage metric. Now that we've gathered all this data, we can explore it in a number of ways. The Data Manager tab allows me to do this. Say for instance I want to focus initially on just statement coverage. I can turn off all the other coverage types that we've gathered and focus on statement. You can see that we're left with one single statement left to test, trigger critical shutdown. I've got various filtering options that I can apply to help me make sense of how the coverage results have been achieved, including selecting coverage from a particular test script, and I can filter for instance by test case.
Well, from that I can see exactly what code coverage this one test case is giving us.
You can see that the Celsius to Fahrenheit test case isn't testing anything in this file that we've got loaded up, but we do have some green here. I've identified that I've achieved 100% statement coverage from that one test case on Celsius to Fahrenheit. A second function in my software under test, Fahrenheit to Celsius, well, I kind of expect my second test case to exercise that, and indeed it does. Turn that on in the filtered view and we can see it go green. So this is a compelling way to help identify what the individual tests achieve, which test cases that have been defined cover which parts of the code. I have additional filtering options here to look at the coverage in different contexts.
Is there a way to use this coverage information to optimize my set of test cases?
Yes, a great feature is the ability to optimize test case selection by coverage. So with Cantata, I can run an optimized coverage routine across my tests and disable any tests that achieve duplicate coverage information. You can see that after applying optimization, test cases 5 and 9 have now been greyed out, and that's because the coverage achieved by those tests has already been achieved by previous test cases. To speed up the test, or maybe simplify my test script for a target environment, I can use that functionality to hone things right down to the set of test vectors required to simply hit my coverage target.
So, we've seen how good data diagnostics makes code coverage analysis really powerful. Pinpointing the gaps in testing and knowing when you have tested enough are both valuable for driving more effective tests. However, as we've also seen, even with a productive test development GUI like Cantata, the biggest challenge is to create all the test cases. For an answer to that, we'll look next at the role automatic test case generation can play.
Automated unit testing is a great way to ensure that your requirements are being met while maintaining an effective team workflow. It gives you a quick way to set up your testing framework with some initial test conditions and allows you to manually verify the automatically generated test cases against the requirements and also supplement those with manual test cases if required. Cantata Autotest creates complete unit test scripts or adds test cases to existing Cantata scripts. It parses the C or C++ code to determine all possible paths through the code, and an algorithm creates test case vectors that exercise all required code paths. It uses powerful white box abilities to set data, parameters, and control call interfaces, and also inserts necessary checks on the expected outputs. There's a number of settings to control the Autotest algorithm. We can set the analysis time and depth of parsing of the code, and then leave the algorithm to determine the test data required to exercise the code under test to the demands of the selected coverage rule set. So I'm just going to leave those settings with default, come back, and we'll stick with our temperature monitor function here. I haven't got any tests set up, so with a single click, Cantata will do a parse of the code and determine all the paths necessary to achieve maximum coverage on that piece of code. And with that, it's done the analysis, generated 4 test cases, and exercised them in my host environment. And I can see I've instantly achieved our coverage target. This gives us a great starting point to then go through and add any manual test cases, or indeed review the auto-generated test cases and look at how those are driving the code and match them up with requirements.
Thanks again, Adam. To explain the whole process, Autotest parses the code and reports what will be achieved in the automatic test case generation. It generates the Cantata tests in standard format and makefiles if needed. It instruments a copy of the source code as needed for white box testing and coverage, builds and runs the test executable, which returns the results as for a normal Cantata test. It's important to note that Autotest is generating the test case vectors from the source code. While path-solving algorithms are faster and more thorough than human testers at generating test case vectors, especially for complex code at the highest levels of coverage, on their own, they only verify that the code does what the code does, which of course is insufficient for safety-critical standards. That's why our customers who are making successful use of Autotest are doing so in combination with Cantata Trace, allowing them to review the generated test vectors against the requirements. QA Systems have published a few white papers on this highly efficient automated requirements-based testing approach, and they're available at our website.
Let's look a little bit closer now at the comprehensive reports generated by Cantata tests, and also their historical and trending data that I can access using the Cantata server component. So we've got our tests here in the Test Explorer. For this one particular testing project, I've got 3 distinct test scripts to exercise the code in that project. And for each test script, I've got a results section that contains the detailed results log. This is a ASCII format results file that contains details of all the checks that have failed and passed across all test cases, and even specific data that may be causing problems for that test. Also in here, we've got full coverage information for the selected test, including statement by statement, decision by decision, and so on. I can use this as a definitive log as to the health of my test. And this is also the log file that's accepted as certification evidence for the main safety critical standards. At the end of the file, there's a summary table, and all of this is useful information to easily identify any issues with my testing. The log file is also available as a HTML version. You select the file, convert to HTML, and this contains exactly the same information but rolled up details for the individual test cases that you can expand out to view in more detail. Again, this is a single HTML file and it can be used as certification evidence for your testing, as can the ASCII results file. In the results folder, I have a number of aggregate logs. let's have a look at the summary HTML report. So this rolls up all of the test data across the various test scripts in this one project. You can see the status of my 3 test scripts here, and individually I can track the coverage information that's being obtained, any checks that are passing or failing, and we've got a useful coverage summary block at the top. Using the Cantata Report Viewer tab, I have additional access to a number of reports for each of my test projects. I can load up, for instance, the test report for the one we're looking at here, and this is a full detailed report that aggregates all of the data across the tests in this one project. It contains details of the behavior of my tests in one single location. It's worth mentioning here that you have the ability to customize these reports by applying XML transforms. They are already the most commonly requested setup in the system. So this is the detailed HTML report. We can switch to the overview report, which is something that we added in on request of a particular customer who wanted just a high-level view as to the status of each test in the project. And we've got full control here. A good example of this is if I switch to the Chinese language reports, just to demonstrate the flexibility of the XML transforms in processing the information into a report style to suit your own particular requirements. So let's close that for a moment and take a look at the report generation options that I can fire off immediately, automatically after running a test. The upload results to server option is particularly useful. Cantata comes supplied with a standalone server component. This runs either as a service on your local machine or another machine on your network, and it acts as a repository to store the test information for a particular test run, or indeed the testing progress achieved by all your team members working on the project. This repository of data can be fed from test runs performed from your desktop environment, or more commonly a continuous integration system configured to run your Cantata tests according to triggers such as new test check-ins, code changes, overnight builds of regression test suites, etc. I can see the individual status of test case passes and fails and trending coverage information across the entire project. And hopefully that will show me that the coverage level and pass-fail ratio is improving as time goes on. I can go into individual test projects and pull those out of the system individually. We can look at sub-projects and drill down into full detail to see the status of each part of my testing effort. If I go into an individual test project, I can view the log files directly. For instance, I can look at a particular test log file and review the timestamps and full details of that particular test run. It gives me the ability to explore the test log in full detail. The data held within Cantata Server is accessible using an API, and using this you can poll individual test logs, pass-fail status, coverage levels and more. Cantata Server also holds details of the requirements tracing, which again can be accessed directly by polling the Cantata Server API. Like all of Cantata, it's a flexible system that can be easily configured to fit with your particular workflow. I'll leave this at the project level, and this is the summary report for all of the testing that's taken place across my organization. In modern workflows, dashboards are critical, allowing anyone to monitor the current state of all tests across all of the projects on your system.
Thanks again, Adam. Looking at the test build and run process, on a development host, you can see there are 2 distinct parts for building a Cantata test, along with the source code under test. A target-specific Cantata library containing all of the framework code for the target platform allows the test script to remain focused on the test driver code, keeping things clean and easy to read. But more importantly, it means that test scripts can be written to be independent of the target platform on which they're executed. This helps us address our last topic today. Will Cantata be right for my project? Developers can therefore build and run both host native and across multiple target configurations, providing results and diagnostics for each across all combinations your project and safety integrity level requires. When executing Cantata tests on a host native platform, the test executable can be downloaded, run, and results directed back to the host over whatever connection type is available. Where full file I/O is unavailable, serial, JTAG, or debug interfaces use an automatic multiplex and demultiplex of data streamed or flushed from the target memory. This flexibility in Cantata extends from the test execution environment to test development and results analysis. Cantata integrates easily with other tools using open architectures like CSV, RecIF, XML, JSON, a RESTful Services API, ASCII text files, and tests fully accessible in C or C++ code. And of course, integration with familiar IDE environments and command line-based SEM and CI tools. To get the best return on investment from a unit test tool, our customers have made the most of the open standard APIs in Cantata to integrate it with their complete safety-critical development toolchain, allowing them to share valuable information between tools. Adam, could you quickly show how to configure Cantata to compile for a target architecture and rerun one of the previous unit tests you looked at?
Yes, of course. Cantata has a built-in deployment editor, allowing you to set the precise options to build for your desired embedded target. Here is the configuration section to set up Cantata to compile, link, and run tests with the IAR ARM compiler and associated simulator. I have precise control over all the build options. I can then switch over to building the Cantata supporting libraries for that environment. Again, there's lots of control available to enable Cantata to run in virtually any environment, including options to execute tests in environments restricted in terms of file system, memory, or even availability of standard library features. Once the deployment is configured, it's a simple matter of selecting my desired build and run environment from a drop-down list. Cantata handles the makefile build system, calling the correct compiler, and even starting up and running tests in the simulator. Of course, if I had target hardware available, I could also flash the test to the real device and monitor its execution in a debugger. In this example, I'm recompiling a suite of tests to execute in the IAR ARM simulator. The test has been downloaded from the host and run in the simulator. The result and reports are available in exactly the same way as shown previously, allowing engineers to easily verify on-device behavior matches between compilation environments. We've no limitations on the target compiler and hardware we support, other than a minimum memory requirement of around 32K. Generally, when it comes to integrating, Cantata works with a wide range of development environments and IDEs, including C and C++ compilers, static code analyzers, manual testing systems, and continuous integration systems.
Thank you, Adam and Matt, for that really interesting discussion and introduction to Cantata. So before we turn to your questions, here's what you told us earlier about yourselves.
So we asked which safety critical standards you are working to, and most of you are working towards ISO 26262. Then we asked which unit test tool you are currently using. Most of you are using Cantata, which is great. For those of you not currently using Cantata, I hope today's webinar has encouraged you to consider it on your next safety critical project. And finally, we asked which is your biggest unit test challenge. Most of you said writing unit test cases. Again, interesting answers which help us to hopefully help you in addressing these challenges. So thank you everyone who has submitted questions. If we do not get to answer them all in time today, we will send an emailed reply to each of you after this webinar. So the first question, how user-friendly is Cantata with test-driven development? Adam, could you please answer that?
Yeah, sure, I can take that one. So test-driven development is kind of a more modern approach to kind of fitting your testing in alongside your development. So they both kind of take place in parallel, or maybe the tests take the test construction takes place slightly ahead of the code generation. So with Cantata, we can take information from single header files before the body of functions has been written and composed, and use that information from the header files to construct a test script. We've also got the stubbing functionality that's great for taking a small element of your code and testing it in isolation of the complete system. So you can use the powerful stubbing functionality in Cantata to kind of replace more complex functions and methods with kind of dummy functions before the full function's been written. So there's various ways you can kind of tackle TDD that way.
Great, thank you, Adam. Let's move on to the second question. Matt, perhaps you can help us answer it. Why is the ISO 26262 test coverage only compliant to 2011 and not 2018?
That's good. That's an eagle-eyed question. So firstly, Cantata was certified to the 2011 version of ISO 26262 and subsequently to the later 2018 version. The code coverage requirements of both of those versions of the standard are actually the same. We have customers who are using the 2011 version and the 2018 version, but we have made the decision at our next release in the summer of Cantata to update the naming of the rule sets. As Adam's mentioned before, the actual numbers in the rule sets, you can actually configure yourselves. You can even create or change the name of the rule set if you so wish.
Excellent. Thank you very much for sharing that, Matt. Moving on to the next question. Can I create a non-100% expectation custom coverage rule set to check against? Adam, would you?
Yeah, I'll take that one. Yes, of course you can. You've got full control over what you're checking for in the coverage rule set. So if you desired, you could set, say, 80% statement coverage and have that as your target. Maybe you'd want to do that if you wanted to set the bar low to begin with and then raise it up as you get towards the end of your project as the code gets built out and completed. So yeah, that's fine. That's no problem.
Great. We have time for a couple more questions. How an automated test script can be updated after a code update?
Okay, well, I can take that as automated test cases are kind of exactly the same as manually generated test cases. So they're individual components within a complete test script. So once they've been generated, you can go in and edit them and manipulate them as if they are manual tests. If you've got additional code being created that you then want to add into a kind of existing test script, you can run another Autotest analysis and generate new test cases based on that additional code. We've also got a facility in the tool which I didn't touch on called code change analysis, and that's a mechanism that allows us to detect changes to your source file and make suggestions as to what you may want to update in your test script to address those changes. So if you alter, say, a function body, add a new function, maybe change a source file or a header file, we can kind of highlight that in the IDE and give you some automated suggestions as to things to update and look at in the test script.
Excellent. Thank you, Adam. Another question we got is how many files must be checked in the version control system to be able to recreate the test environment on other machines than the one used for the test development? Adam, could you answer that first?
So, I mean, it's obviously not an exact number. It depends on kind of how many tests you've got and how complicated they are. But fundamentally, the test script itself is written in C and C++. So that's the important thing to manage alongside your code. So the test script is key. In addition, there's an options file. It's got a .cop file extension, and that contains all the instrumentation options that get fed through to Cantata. So things like what code coverage you're going to be gathering, whether you're using some kind of white box facilities using the Cantata wrapping functionality. So that would all be stored in this one options file, and again, it's sensible to manage that alongside the test script. And I guess the other thing is the makefile build system. So as you're generating tests inside Cantata, Cantata will maintain a collection of makefiles to enable you to easily rebuild we compile, we link, and execute those tests. I guess it's not strictly necessary to kind of manage those, but it would make your life easier. So you're storing your build system alongside the code and the tests.
Georgia, can I just add something to that? I think it's worth also pointing out that in any safety critical environment with Cantata, we have a safety manual alongside the standard briefing. The safety manual has a specific use case around the control of the artifacts for certification evidence as to what is checked in and what is reviewed and what's supplied to the certification body. So all the things that Adam has mentioned, there are on certain types of tests, other files as well. So that might be dependency resolver logs, it might be additional files for data sets pulled in by test scripts, etc. But all of that is documented in detail in the safety manual to ensure that a user can do it both across different environments and remain certified.
Excellent. Thank you for that, Matt and Adam. Well, guys, our time is up. So thank you again for joining the webinar, and thanks again to Adam and Matt.
Thank you.
If you'd like to learn more about how to accelerate your unit testing of safety critical software or request a trial of Cantata, please do visit our website. Thank you for watching. Goodbye.